Hi everybody, welcome back to TFP TV. Today we're going to be talking about water test using the API Freshwater Master Test Kit, as well as API's General Hardness and Carbonate Hardness Test Kits. And we get a lot of questions here at the store of why do I need to test my water? Everything looks clear, it looks fine. Well, water testing is one of the most important things you can do to make sure that your tank is healthy. It's just like if you go to the doctor's office, they always take your vital signs. These are the vital signs for your aquarium. As far as how often you want to test, that really depends on your tank. If you notice you have a problem with your tank, testing the water is the very first step you want to do. Also, when you're doing water changes, whether it's once a month or once a week, it's a good time to test your water just to make sure that everything is still doing good. We do recommend keeping track of your test results. You can use a water test result record like we have here at the store, or you can just get a notebook and write down all your test results, as you get them. So then you remember what your test was last week and you can make sure everything is still trending really good for your tank. So the test kit we're going to be using today is API's Freshwater Master Test Kit. Now this has the 4 major tests that you want to do. The first one being pH. It has both the regular and high range pH test, and ammonia, nitrite, and nitrate. Those 3 tests make up what we refer to as the nitrogen cycle. This is what happens when the bacteria in your tank establishes to take care of the waste and will make sure that your tank stays stable. So this also includes the test vials that we're going to actually do the tests in, as well as an instruction manual and the color chart that you're going to use to compare the vials to once we're finished doing the test. So the first test we're going to do is the ammonia test. Now ammonia is very important to test because it affects the fish health. It's one of the most toxic chemicals. The ammonia really affects how well the fish can breathe. It is very acidic, so it can burn their gills and affect how well they can absorb oxygen. Can also cause ammonia burns on the rest of their body, as well as affecting the water clarity and stability. So for this test, we're going to need one of our test vials. Now these vials are marked with a white line. It's a 5 milliliter line. So we're going to take our water sample. You can collect your sample in really any clean container. You want to make sure it doesn't have any food leftovers in it, any soaps, detergents, anything. If you don't have a clean, dedicated container, you can use a Ziploc baggie or another plastic bag. And I am going to use a clean eyedropper. You can also use a small measuring cup if you want to, carefully dump some in. Anytime you fill a test tube, you're going to see what's called the meniscus. That is a little dip right at the top, and it just forms because of the water tension. And you want to make sure the bottom of the meniscus is right at the line. So now that we have our sample, we're going to take our bottles. The ammonia test is 2 bottles, and it will say bottle 1 and bottle 2, and it also says right on there how many drops you want to add. This one is 8 drops for the bottle 1. You just want to give it a little shake, make sure all the reagent is mixed in. Hold it straight upside down and do 8 drops. 2, 3, 4, 5, 6, 7, 8. And for this particular test, you can add the second reagent right away. You always want to make sure that you're following the directions very carefully, because some of these you do want to shake first or wait before you add the second one. But this, we're going to add 8 more drops of the second one. And now that we have both of our reagents in, we're going to put the cap back on and just invert it a few times to mix it. You don't have to go super vigorous with it. You can, but just inverting it is enough. And you do want to make sure that you take the time to put the cap back on before you shake it. Resist the temptation to put your finger on it, because that will affect the results. And this test takes 5 minutes to develop. So we're going to give this one 5 minutes for the color to develop fully. So the second test we're going to do is the second stop in the ammonia cycle, that is the nitrite. Now nitrite is also very toxic to aquariums. This affects how well the fish can absorb oxygen into their bloodstream. So this one is just a 1 reagent bottle. Now this one, we want to add 5 drops to it. Again, we're going to fill up to the 5 milliliter mark. And I'm going to make sure the bottom of the meniscus is right at the line, so we have exactly 5 milliliters. And add 5 drops. Now this test is also going to take 5 minutes to develop. So we are going to let the color on this one develop fully, and we will come back and check the results in a few minutes. The third test we're going to do is the nitrate test. Now this is the end product of our nitrogen cycle. This one is not as toxic as the ammonia and the nitrite, but you're always going to see it at the end. You know, it's going to start stressing the fish out. You're going to see other problems develop, like algae and waste building up. Now, nitrate is a 2 reagent test, so we're going to add 10 drops of reagent 1 and 10 drops of reagent 2. This one is very important to follow the directions that are written in the pamphlet, because it is very important to pay attention to the timing on these and also making sure that the reagents are mixed up properly. So we have our 5 milliliters, and we're going to start with bottle number 1. Now this one, we just want to give a little shake, make sure that everything is dissolved, and we're going to add the 10 drops. And once again, we're going to cap it, invert it, make sure the first reagent is mixed in. Now for the second bottle, this is where it's important to follow the instructions, because you do need to shake this bottle very vigorously for at least 30 seconds to make sure that all the reagent is mixed in and you're not going to have any settled at the bottom. Make sure it's a proper concentration for the test. Okay, so now that we have this mixed all the way, we can reopen our test tube and 10 more drops. And one more time, following the instructions and not taking any shortcuts, want to mix it for a minute. Now this is one of the longest tests to develop, since we do have all that time that we need to make sure everything is mixed. It also does take 5 minutes to fully develop in the color. So you can do this one at the beginning if you'd like to get it started while everything else is developing. Now that we have this shaken up for a minute, we're going to set this one aside with our other test, give it a few minutes to develop. And the last test that we're going to do as part of the Freshwater Master Test Kit is the pH. Now the pH is a measure of the acidity of the water. Most tanks are going to be around 7.0, which is the middle of the range, which goes from 0 to 14. Some tanks, depending on the type of tank you have and the type of fish that you would like in it, may require a lower or higher pH. It just depends on the type of system that you have. The regular pH test goes up to a pH of about 7.6. If your pH in your tank is above that, or you notice that this is at the top of the chart that we'll take a look at later, then you want to use the high range test kit, which goes from about 7.4 to 9. So there is a little bit of overlap in there. So if it seems like you're at the higher range of the regular pH test, you can run the high range as well, just so you can pinpoint a little more specifically where exactly you are. Okay, so for the regular pH solution, this is a very quick 3-drop test. So just like the other ones, we'll add our drops in and mix it. The main difference between this test and the other ones that we did, this one you want to compare the color immediately. You don't need to let this one develop for 5 minutes. So we're going to take a look at this one. And it's also very important whenever you're looking at test results, look at them on a white background. Obviously holding them right over top of all the little colored boxes or on top of, for example, our blue tablecloth here is going to affect the color. So you want to make sure that you're looking at them on a white background. So I'm going to pull over our test record here. Now comparing this to our chart here, we see that the color of our pH test looks like it's about that 7.6 mark. Now if you would like at this point, you can double check that value, go clean out your test tubes, and you can run the high range pH test kit, and then you would compare it to this next chart here, which goes from about brown to purple. With this 7.6 test result, this sample came from one of our freshwater community systems. For those systems, generally a pH of anywhere between about 6.8 to 7.6 is perfectly acceptable for those tanks. For some specialty tanks like African cichlids, you would need a much higher pH, usually about 7.8 to 8.4. There's some freshwater tanks that also need a much lower pH, below 7. So determining the correct value for your tank really depends on the type of tank that you have and the types of animals that you have in it. So for this particular system that we tested, 7.6 is a perfectly acceptable result. If the tank you have needs a different pH than about that 7.6, this is when you would want to look at how you can get your pH to that proper level. So now that the rest of our tests have had a chance to develop, we can go back and take a look at our results for the other test. Now the first one we did was the ammonia test. Now this one we're going to compare to this yellow to green chart on the side here. Now this test looks like we're right up at 0. So we don't have any green in there. Everything is nice and yellow. That is exactly what you want to see for an established system. If you have any green in here, especially once you get down towards the bottom, that's going to be very dangerous for the fish and animals and plants in your tank. Now, a lot of new tanks, if it was just set up and hasn't gone through the nitrogen cycle yet, it's very common to see ammonia in those tanks, since we have to wait for the bacteria to colonize in the tank that's going to take care of that waste. But if you have an established tank and you're seeing high ammonia, we really want to figure out why. It could be something like overfeeding. If you have too much food in there that's decomposing, it could be a tank that's overstocked or underfiltered, in which case you would want to look at what you have in the tank and how we can get rid of the cause of the ammonia in that tank. But for all established tanks, we really want to see that yellow color, which is what we have, so we're in good shape for the ammonia. Now going to our nitrite test next. Now this, again, comparing it to the white, we're going with the test here that's going from baby blue all the way down to purple. Again, for an established tank, we really want to see 0. Any nitrite is a sign that something's going wrong in an established tank, which it looks like for this. We have that bright blue color, so we're in good shape for the nitrite for this system. Just like with the ammonia, it's expected to see a spike in the nitrite in tanks that aren't established yet. Usually we'll see this right after the spike in ammonia. Once that goes down, we see a spike in the nitrite. But if your tank has been established for a while and you're seeing high nitrite levels, then we want to get to the cause of why. Usually, again, overfeeding, decomposing food in the tank, overstocking, pretty much some of the same causes as for the ammonia. But established tanks, 0 is exactly what you want to see. Okay. Going on to our last test, which is the nitrate test. I'm going to compare this to the yellows to reds on the end. This is one of the trickiest tests to see the color because they are all very similar to each other. But looking at this test, looks like we're right around the 10 parts per million level, which for most tanks, you really want to see that level for the nitrite below about 40 parts per million for some freshwater tanks. For tanks with sensitive fish or plants or saltwater tanks, you really want to see that below about 10 to 20. So for this tank in our freshwater system, 10 parts per million is a really good level to see. Now, if you are seeing higher levels for the nitrate test, that's going to be when you want to start maybe doing more water changes to your tank, doing them more often. Make sure your tank isn't overstocked or overfed, just like the other ones. Also, depending on the area that you live and where you're getting your water from, if you constantly see high nitrate tests, you might want to run the same test on the water that you're using, whether it's out of your tap or well or any other water source. Some regions, especially if you have a lot of farms and gardens around you, you might naturally have nitrate in your water, in which case water changes are not going to help you get rid of it. Now, if you do have nitrates in your water, you can make sure that you're using cleaner nitrate-free water, using an RO unit or a DI unit, which are different types of filtration on your source water, or switch to a source like spring water, bottled water, something like that that doesn't have nitrate in it. You can also use filter medias like resins, depending on the type of filter you have. You're going to put those in your filter and it'll help take any of the nitrates out of the water before it goes into your tank. Okay, the last tests that we're going to talk about are not included in the API Freshwater Master Test Kit. These tests are the GH and KH of your tank. These are the water hardness levels. Now, GH and KH are very similar to each other. GH just means general hardness. This is measuring all of the minerals and everything that is in the water. KH stands for carbonate hardness. This measures the calcium carbonate in your water. This is important to measure for the buffering capacity. If your KH is very low, it'll let the pH swing all over the place. It doesn't buffer it and hold it in place. If your KH is very high, that means it has a high buffering capacity. That means it'll keep your pH stable wherever it is, and it'll make it harder for you to adjust it if the pH isn't starting out somewhere that you want it. Okay, now the GH and KH test kits are much different than the other ones that we did that involve adding the reagents and then comparing 5 minutes later to see the color. For these tests, we're going to add drops one at a time and see how many drops it takes for us to reach the final end color. So we're going to start with the KH test. Now this test is going to start out blue, and we're going to measure how many drops it takes for us for this test to go from blue to yellow. Okay, so for this one, I added 3 drops to start out with because I know that our hardness is going to be over that level. So we're starting out with the blue color. Now I'm going to add drops one at a time until we reach the final yellow point. You'll notice as you start adding the drops to it, you can kind of see the color change happening there. As we approach it, once you mix it, it'll turn back. But you see that now we're at 6 drops and we've gone completely yellow. So that means that our KH is 6 degrees of carbonate hardness. For most tanks, most freshwater tanks, that's about where you want to be. For hard water tanks, like African cichlid tanks, saltwater tanks, you want about 8 to 12 degrees of carbonate hardness. For soft water tanks, like some of those from South America with some types of tetras, you might want less than that. But 6 degrees is a good level to make sure that your pH is going to stay stable, since we are measuring, again, the buffering capacity of the water here. So next we're going to do the general hardness. Now again, the difference between these two, general hardness measures all of the minerals in the water. Carbonate hardness is just measuring the calcium carbonate levels. So for this one, we're going to be going from orange to green instead of blue to yellow. So we're going to start with 3 drops since that's what we started out with the other one. And I know we're going to have at least as many degrees of general hardness as we did in carbonate hardness, since carbonate hardness is part of the general hardness. So we're starting out with that orange color. And once again, we're going to add 1 drop at a time until this turns green. Okay, so we're up to 6 drops in the general hardness test. Now we know, since the carbonate hardness was 6 degrees, we know general hardness is going to be at least 6, since the general hardness includes what we already measured in the carbonate hardness. So now I am up to 8 drops. Again, if you keep an eye on the color, you'll notice when it starts getting close, because when you add that drop, the color change will start being a little more obvious each time. So now we're up to 10 drops, and the test has turned from orange to green. Now general hardness, unlike the buffering capacity we measured here, is part buffering capacity, but overall hardness. So when you hear anybody referring to they have hard water, that's going to be the general hardness. If you hear that the fish you're interested in prefer soft water, you want to measure the general hardness to make sure that your water is soft. Now at 10 degrees of general hardness, we have fairly middle of the road to slightly hard water here, which for the freshwater system this came out of is perfectly acceptable. Now, if you notice that the fish and animals and plants that you would like to keep need a different hardness than what you're seeing in the general hardness test, that's when you want to make sure that you're modifying the hardness. You can use minerals, substrates, different types of additives to help you raise or lower the hardness to make sure that's within the level that you need for your tank. Okay, now that we are finished testing our tank, we've determined that all of our levels are exactly where we want them to be. It's time to clean up. Now with these test tubes, it's very important to rinse everything out very thoroughly when you're done. You don't want any reagents, any type of color that you can see left over in these. And you want to make sure that you're cleaning them out under running water. None of these chemicals are extremely toxic or dangerous, but they are chemicals. So you do want to make sure that they're rinsed out thoroughly under running water, and as soon as you're done, to make sure that they're out of reach of any children, animals, anything that can get a hold of them.